So for this question, express 1 over x squared plus 1 in partial fraction. Hence, evaluate the defined integral for this fraction. So first step, identify if proper or not. So this is proper fraction. Continue. Second step, look at the denominator here. Is it this quadratic factorized completely? Is it this quadratic can be factorized anymore? Can be factorized or not? X squared plus 1 can factorize or not? Can test your calculator and see. Quadratic. This one already factorized or not? Can be factorized or not? You get imaginary number. You get I. So I means cannot factorize anymore lah. You get imaginary number means this quadratic don't have real roots, means cannot factorize anymore. Means this factor will remain at quadratic. Then we split according to factor linear and factor quadratic. Factor linear, numerator constant. Factor quadratic, numerator here, linear, bx plus c. Then we get same to the denominator, a you time with x squared plus 1. And then bx plus c you put in bracket so that it multiply with x. Without bracket, it will be a careless mistake, just c multiply with x only. Alright, then from here, we have to identify whether we want to use let method or comparison method. We have ABC, we have 3 unknown. So supposedly if we let, we have 3 value. From here, we only get s equals to 0. So we still need 2 random variable, 2 random number. So for 2 random number, it will come out 2 simultaneous equation. So like a bit longer the step. So it will be start with let x equals to 0, then we continue with comparison method to avoid the simultaneous equation. Alright, so we use one of the roots first, which is x equals to 0, to find out one variable first. So when x equals to 0, it gives us a. Alright, so for let method, we did not continue as we use random variable, random number x1, x2, it comes out simultaneous. So we skip that, we do comparison. Substitute your a as 1, bx plus c, then we compare, we expand and compare. You will have x squared plus 1, here we'll have bx squared plus c x. So your quadratic will be b plus 1 for x squared. Continue for the x term, cx, continue with the constant. Therefore, by comparison, b plus 1 have to become 0, so b equals to negative 1. Cx also need to become 0, so c is 0. Then lastly, constant is 1. Alright, so your partial fraction will be 1 over x squared plus 1, where a is 1, b is negative, c is 0, so negative x. Negative we take out. Then we continue for the part for integral. To integrate e is square 1 over x squared plus 1 dx. Substitute our partial fraction form, which is 1 over x minus x squared plus 1 dx. So all of this is testing about integration using fraction. So for this formula for special form, integrate fx prime x, it can be equals to ln fx plus c. We can see this is fx x squared plus 1. When we differentiate, it's supposed to get 2x. So means up here, we need to times 2 and then divide by 1 over 2. Alright, when I rewrite this, it will become integrate e squared 1 over x dx minus 1 over 2 integrate e squared 2x over x squared plus 1 dx. So that we can get the pattern. This is fx, up here is f prime x. We use formula special form, so integrate that. Integrate 1 over x ln. So integrate fx, f prime x also give you ln. Then we substitute upper limit minus lower limit. So ln e squared minus ln e, this is ln e4 plus 1 minus ln e squared plus 1. Ln e simplify to be 1. Then 2, this one move to the front, simplify to be 1. Therefore, that part, 2 minus 1, 1. Minus 1 over 2. Ln minus ln, item can be divide. So in order to get, this is your final answer already, but if you want to get to the answer in the pattern in your final answer, this is positive, right? In your final answer at the sheet at the back here, this is positive, right? So how to get to that pattern? You inverse this. You inverse this. So e2 plus 1, e4 plus 1, power to negative 1. Terbalikkan jadi power negative 1. So power move to the front, 1 plus 1 over 2. So this is the answer at the back. But this one also consider final answer already. Also can be accepted.